Hello, Chem 1. In Unit 1, we talked about how to measure, why measurement is important, and what makes digits in measurements significant. Today we're starting Unit 2, and 2.1 we will learn about matter, which is what we study in chemistry and the properties that help us categorize it. Matter has many ways to be categorized. One of the ways is with intensive and extensive properties. Intensive properties are properties that are independent of the sample size, meaning that that property will not change no matter how large of a sample you have. I like to say intensive properties are so intense they never change, which is weird, but it helps you remember the difference between intensive and extensive. Extensive properties are dependent on sample size, meaning that they'll change, or the property changes depending on how much of it you have. A physical property is any quantity or quality that can be observed without changing the identity of the substance. In other words, I don't need to light it on fire or have it go through some kind of chemical reaction to observe it. I can just pick up the object and observe the physical property by looking at it. So let's take a look at some physical properties and identify whether they're intensive or extensive. First one, state of matter. So solid, liquid, gas. So the question you should be asking is, would the state of a solid, let's say, change if it was larger? And the answer is no. And so therefore, state of matter is intensive, because it doesn't matter how much of that substance you have, it's still going to have that state of matter. Next one, color. Does something's color change when you have a larger sample size? No, that's intensive. Size. Does something's size change when you have a larger sample? Yes. So size would be extensive, because as the size of the sample grows, the size changes. With odor, the strength might change, but the odor, the actual smell, is still the same. So therefore, odor would be intensive. Texture. If something has a texture with a small sample, it's going to have the same texture if it's a larger sample. Luster. This is how it reflects light. If it reflects light as a small sample, it's going to reflect light as a larger sample. It might reflect more light, but the property that it actually reflects is still the same. Mass. As the size of a sample grows, the mass is going to change. Therefore, that's extensive. Volume. Volume's going to increase. Extensive. It will change. Hardness. Usually hardness is rated on a scale, like from 1 to 10, and you might have more of it, but once again, the actual value of that hardness should stay the same, and therefore that's intensive. Density is an intensive property. The density of water is 1. If I have 1 milliliter of water, the density is 1. If I have 100 gallons of water, the density is 1. Okay, so that's intensive. Temperature. Okay, if you have a little piece of something that has a temperature of 50 degrees Celsius, if you have a larger piece, it can still have that same temperature, which is different than heat content. Heat content is the total amount of heat something can hold within a system. So if you have more of something, it can hold more heat even if the temperature is the same. For instance, if I have a drop of water at 50 degrees Celsius and I have a gallon of water at 50 degrees Celsius, even though they're the same temperature, the gallon has more heat content or more heat within the system. So therefore, heat content is extensive. It does change with the size of the sample. Solvation is the process of the solvent interacting with the solute. That's intensive. It won't change with the size of the sample. Solubility is intensive. It won't change. No matter how much you have, it will have the same solubility. pH is intensive. If it has a pH of 6, doesn't matter how much you have, that's the pH. Conductivity, if it conducts electricity, that's intensive. Magnetism, no matter how large of a sample of a magnetic substance you have, it's going to be intensive. And then malleability is also intensive. Ductility can be drawn into thin wires, just like malleability, that'd be intensive. If something is brittle, that's intensive. Miscibility, that would be if you can combine two liquids and they'll dissolve into each other. That property won't change with the size of the sample. Viscosity, which is like resistance to flow, like maple syrup would have a higher viscosity than water. That's intensive. Doesn't matter how much you have, the viscosity of maple syrup is the same. Surface tension. Once again, that's intensive. Doesn't matter how much you have. If it has surface tension at a low amount, it'll have the same surface tension. And MP, BP is melting point, boiling point. The melting point of a substance or boiling point of a substance will not change with the size of the sample. So the list here, first of all, these are all physical properties. I can observe all these things without any chemical reaction. That's number one. Number two, hopefully that helps you understand the difference between intensive and extensive. Remember, intensive is so intense it doesn't change with the size of the sample. All right, let's move on to chemical properties. These are properties that you can observe, but you have to go through the changing of the substance. There has to be some kind of chemical reaction taking place. So there's not quite as many here. Reactivity would just be how reactive it is, what it will react with in its environment. Corrosivity. Is it corrosive? Will it eat away and decay? Like, for instance, rust is a corrosive reaction, an oxidizing reaction. That would be intensive. It doesn't matter how much of the substance you have, it's corrosive no matter what. Causticity would be, can it burn or corrode in specifically body tissues? Would it be dangerous to have open skin around this substance? That is also intensive. And then finally, flammability. Will this combust? Will it burn if it gets to a certain temperature? That would be our last chemical property, which is also intensive. What you'll notice about chemical properties is they are always intensive. It doesn't matter how much of a substance you'll have, the chemical properties will always be the same. One last time of properties here is nuclear properties, which is any property related to the instability of an atom's nucleus. We will go through nuclear decay and talk about nuclear decay later this year. Really, the only nuclear property we're going to talk about is radioactivity, which is an intensive property. When something emits a alpha or beta particle or some type of radioactivity, that would be intensive. Last thing here about these properties, some of these properties, specifically the physical ones, will change depending on the environmental conditions. A good example of that is boiling point and melting point. Boiling point and melting point are based on the pressure within the atmosphere. Okay, if you have a cup of water, there's a pressure, there's vapor pressure, okay, which is that liquid trying to become a gas, but there's also atmospheric pressure pushing down on the glass of water. So in order for something to boil, that atmospheric pressure has to be overcome. Well, depending on where you are, even in the United States, say for instance Centerville or Denver, that atmospheric pressure changes, and therefore the boiling point will slightly be manipulated based on the pressure in the air that day. So even though we consider boiling point intensive, environmental conditions will still play a role and can still change those intensive properties. Typically, when we talk about those things, we're talking about under standard conditions. That's all we really wanted to talk about today with day one. You need to know about physical, chemical, and nuclear properties and how that relates to the terms intensive and extensive. Good job today. We will see you soon.